This is Ziram Babu, working as lecturer in Government Polytechnic Vaddepalli. I'm dealing subject for diploma first year mechanical engineering student for second semester. Subject name is Advanced Workshop Technology. Subject code is 18M205C. So topic is today we are going to discuss about mechanical working of metals, and subtopic is mechanical working of metals. And teaching aid is photos and animation diagrams. And previous class we are discussed about in the previous class we learn the observable characteristics of material or cold properties. One is the observable characteristics of material or called properties, and the characteristics of material under influence of external load or mechanical properties. The characteristics of material under influence of external loads or mechanical properties, and definition of various mechanical properties. Definition of various mechanical properties, like we are discussed in yesterday class: ductility, malleability, fatigue, stress, strength, toughness, hardness, creep, and stress, strength. We are discussing previous class. These are the definition of mechanical properties, and definition of mechanical properties is based on their strength, based on their type of material. They are going to be changed their behavior. They are getting they're getting behavioral changes in a object. Is called mechanical properties. That is based on the different factors. And objective is today class objective is, on completion of this period, we would be able to know introduction about mechanical working of metals, introduction about mechanical of working of metals, and classification of mechanical working of metals, and what is hot working, and advantages of hard working and disadvantages of hard working. Okay. Objective of this class, and completion of this period, you will be able to know introduction about mechanical working of metals and classification of mechanical working of metals, what is hard working, and advantages of hard working, disadvantages of hard working. Okay, coming to examples of these. Coming to example of this is a mild steel bucket. This is mild steel bucket. If you are observing in market, we have different types of buckets to carry the water one place to another place, depending on our requirement. Depending on our requirement, carry the liquids or solid. Mostly we are going to be carrying in this buckets mostly liquids. As a liquid, we are taking that liquid into the bucket. We can carry, we can transfer the one place to another place by using buckets. So in coming to market, in the market, we have different types of buckets. We are going to be design the buckets with help of different type of materials. If you are observing in market, we have seen galvanized. We can manufacturing, we can designing the that buckets with help of galvanized iron sheets, and as well as somewhere we are using aluminum also. We are using aluminum material, and somewhere we are using mild steel also. So this is a olden days. We are going to be using mild steel to design the buckets. After that, next somewhere we are using galvanized iron, and somewhere we are using aluminum iron. Aluminum, sorry. Okay. This is an example, and coming another example one is this is a copper buckets. Copper buckets. Brass also we are somewhere we are using brass buckets also. Okay. Coming to copper bucket. This is a copper bucket. This is a handle and to hold the buckets and to carry the one place to another place with the help of a handle only. Okay. And example, another example is galvanized iron. Already we are discussed it, and these are the different types of materials. Somewhere we are using iron, aluminum, galvanized iron, and copper. Somewhere we are also using brass. Mechanical working of metals. Coming to mechanical working of metals. All the parts shown in examples are manufactured by using metal working or metal forming techniques. Either what we are taking, either aluminum, galvanized iron, and mild steel, and brass, copper, whatever we are taking the material, the all type of material, all parts we are shown in example are manufactured by, we are manufacturing by using metal forming process, metal forming or metal working techniques itself only. Okay. This is only by using metal forming, either metal working, and which involves the plastic deformation of metal under the action of externally applied force. The action of externally applied force, which involves the plastic deformation of metals, which involves the plastic deformation of metals under the action of externally applied force. Externally applied force. So plastic deformation of metal under the action of externally applied force. We are applying the some force on a body. Next, and the mechanical working of metals means that internal deformation of metals plastically under the action of applied force. Mechanical working of metals, mechanical working of metals means the internal deformation of metals plastically under the action of applied force. Under the action of applied force. Mechanical working of metals means that internal deformation of metals plastically under the action of applied force. During mechanical working, no cutting or shaping operation is required. During mechanical working, and In mechanical working process, there is no cutting and shaping operation as required to fold or to manufacturing that product. And coming to types of mechanical working process, mechanical working process, hard working, cold working. Mainly we have two types of workings are there by using mechanical working process, and uh, what are there, hard working as well as cold working. Coming to hard working, definition of hard working: the plastic deformation, shaping of metals above the recrystallization temperature is called hard working process. So definition: the plastic deformation. It means plastic deformation means shaping. We are going to be shape that product in required size and required shape of metals and above the recrystallization temperature. Above the recrystallization temperature. So temperature is not too high, not too high, and gives grain growth, deformation and recrystallization to simultaneously. Deformation and recrystallization take simultaneously, and no distortion of grains, no distortion of grains. Deformation and recrystallization takes simultaneously. And coming to hard working, coming to hard working, hard working. This is a hard working. So this is a working principle of hard working process, and original course grind structure. This is a object. This is a original course before we are taking what we are taking as a raw material. When we are taking the raw material, and that time of raw material, there is a original coarse grain structure. This is a original coarse grain structure, and after hard working process, they are getting, this is a elongated grains and recrystallization takes place. This is a after completion of working metalworking process. This is a, this side is before working of hard working process. This is a after of hard working process. They are getting different structure before and after. When we are adding a temperature above the recrystallization temperature, then their grains will be change. And coming to less power to work, less power to work, and better grains produced, and cold working. And definition: the plastic deformation, shaping of metal below the recrystallization temperature. This is also similar, only temperature ranges is different when you are compared to hot working as well as cold working process. Okay, so coming to cold working process, main thing is here we are providing the temperature below the recrystallization temperature. And coming to hard working process, here we are providing the above the recrystallization temperature, above the recrystallization temperature. That's it, nothing is different. And depending on their working process, either hot or cold working process, they are going to be get different grain size and grain structure. Okay, hard working process, less power to work, better grain produce. And coming to cold working, the plastic deformation, shaping of metal below the recrystallization temperature. And performed at room temperature, reducing grain growth, performed at room temperature, reducing grain growth and distortion of grains, and done for dimensional accuracy after hot working. Performed at room temperature, reducing grain growth and distortion of grain will be happen due to below the recrystallization temperature. Then the grains will be, they are getting closed surfaces. So due to that closed, their distortion of grains will be happen, and done for all dimensional accuracy after hot working. Okay. Next, coming to cold working, that is a working of cold working process. Here we have two rollers. One is a fix. This is a work, that is the object. Means work is raw material, what we are taking as a raw material, and elongated grains are produced. Mm, close tolerance are possible. And better surface finish. Better surface finish. Better surface finish. Difference between cold and hot working. So coming to difference between cold and hot working process, and first is coming to cold working. Below the cold working process, in cold working process, we are providing the we are heating the object below the recrystallization temperature, and hot working, and here we are providing above the recrystallization temperature, here below the recrystallization temperature, and no transformation in grain structure, and new grains are formed in hot working process due to high heat. When we are providing heat above the recrystallization temperature, then what will happen? New grains will be formed due to high temperature. Considerable deformation, more extensive deformation, advantages of hot working process. Advantages of hot working process. Extensive deformation. Advantages is, first advantage is extensive deformation. Coming to increased plasticity. Annealing is not required. No strain hardening, and power required. Mechanical properties are improved. And grains refinement, and porosity eliminated, and impurities uniformly distributed. Coming to disadvantages of hard working. Tooling cost is high. This is very important in before going to be choosing the hard working process. Tooling cost is very high. and poor surface finishing, and scale formation on the surface. Scale will be formed on the surface of the object. Scale will be formed due to hot working. It means high temperature. Due to high temperature, scale will be formed on an object. And, due to that scaling, cannot be get good surface finish of the object when you are compared to cold work. Next, coming to rapid acceleration. Acceleration, uh, not meant for close dimensional tolerance. Not meant for close dimensional tolerance. Not meant for close tolerance of dimensions. Again, we can discuss overview of this topic. Recap means in this previous class we have learnt the observable characteristics of material are called properties. The characteristics of material under influence of external loads are mechanical properties, and definition of various mechanical properties, and objectives. And completion of this period we will be able to know introduction about mechanical properties of metals, and a classification of mechanical working of metals, and what is hard working, and advantages of hard working, and disadvantages of hard working. So main objective of this class, what we are going to discuss today, introduction about mechanical working of metals, next classification, and what is hard working, and advantages of hard working, and disadvantages of hard working. So coming to examples of that images, example is for mild steel bucket. This is an example of mild steel bucket. And the next example of buffer bucket, and example of GI seat bucket, what we are called galvanized iron bucket. Galvanized iron bucket. We are also called it as GI seat. GI buckets. We are also called is GI bucket, galvanized iron, and mechanical working of metals. Mechanical working of metals. All the parts shown in the examples are manufactured by using metalworking, metalworking as well as metal forming techniques itself only. Okay. So what we are seeing in previous diagrams, GI buckets, galvanized buckets, copper buckets, all parts they are manufactured by metalworking or metal forming techniques only. Okay, which involves the plastic deformation, of metals under the action of extremely applied force. Extremely applied force. Next, mechanical working of metals means the internal deformation of metals plastically under the action of applied force. Mechanical working of metals means the internal deformation of metals plastically under the action of applied force. And during the mechanical working, no cutting or shaping operation is required. During the mechanical working, no cutting or shaping operation is required. Type of mechanical working process. Hot working, mainly we have two types of mechanical working process are there. The name it is hot working and cold working. So coming to hot working, definition of hot working is mainly the plastic deformation, shaping of metal, which is we are applied the, which is we are forming or shaping in above the recrystallization temperature, above the recrystallization temperature. So temperature is not too high, not too high, and gives grain growth and deformation and recrystallization takes simultaneously. Deformation as well as same recrystallization takes simultaneously. No distortion of grains. No distortion of grains. So coming to hard working, this is the diagram of working principle of diagram of hard working process. So here we have see here here we have two wheelers, upper roller and a down roller. So here we have two rollers. They are going to be revolving. They are going to be rotating in opposite direction. Okay. They are in rotation in opposite direction. I don't know something. Opposite direction. This is the object. So see here, the diagram is before the rolling is the grain. If you are observing, this is very not in closest surfaces. So when you are observing after hot rolling process, see here, this is the grain is very closely here. So that is the main difference. It means virginal coarse grain structure before operation, and after this is a elongated grains after hard rolling process. Less power to work, uh, less power to work, and better grains produce. Cold working process. A definition: the plastic deformation. It means shaping of metals below the recrystallization temperature. Below the recrystallization temperature, and performed at room temperature. Performed at room temperature, and reducing grain growth, and distortion of grains, and done for dimensional accuracy after hard working process. After hard working process, and cold working process. That is the image of cold working process. And see here also we are providing two rollers. They are going to, that two rollers, they are going to be revolving in opposite direction. One is they are going to be revolving clockwise. Another one is they are going to be revolving in anti-clockwise direction. Same, and it is a virginal grain goats. See here, this is a after grain working process, cold working process. This is a grain growth, and the elongated grains are produced. Elongated grains are produced. Close tolerance are possible. Close tolerance are possible. Better surface finish. Better surface finish. And coming to differences between cold working as well as hard working process. Cold working and hard working process. Below recrystallization temperature, and hard working process above the recrystallization temperature, and no transformation in grain structure in no transformation in grain structure, and the hard working process, new grains are formed due to high temperature. And coming to considerable deformation will be obtained here. More extensive deformation, more extensive deformation. Advantage and hard working process: extensive deformation, increased plasticity, and annealing is not required. No stress hardening, power required. Power required. So advantage of hard working: mechanical properties are improved. Mechanical properties are improved. Grain refinement, porosity eliminated, and impurities uniformly distributed. So main advantages of mechanical properties are improved due to hard working process, and grain refinement and porosity eliminated, and impurities uniformly distributed. So coming to disadvantages, and tooling cost is high. Poor surface finishing, scale formation on the surface, rapid oxidation, not meet for close dimensional tolerance. Coming to summary, and in this class we have studied mechanical working of metals, and type of working with metals, hot and cold working, and differences, less power in hot working and better surface finish in cold working. So in hard working process, we cannot be get good surface finish of the object. In coming to when we are coming to cold working process, we are getting better surface finish in cold working process. And the hard working gives better mechanical properties, but tooling cost is more. So in hard working process, will we get a good mechanical property. That is the main advantage. When we are required the good mechanical properties of the object, then we are going to be prefer the hard working process. And but main disadvantages in this is but tooling cost is more when we are compared to cold working process, which coming to page. In cold working of metal, the temperature of metal is in cold working of temperature, the temperature of metal is room temperature, higher than the room temperature, above the recrystallization temperature, and below the recrystallization temperature. So in cold working process, we are going to be producing below the recrystallization temperature. Cold working process, below recrystallization temperature we are providing, but in hard working here is given wrong answer, but answer is below the recrystallization temperature. This is not this answer. Answer is below the recrystallization temperature in cold working process. Okay. And frequently asked question, and what is hard working, and what are the advantages of hard working, and what are the disadvantages of hard working? What is hard working? What are the advantages of hard working? What are the disadvantages of hard working? Difference between hard working and cold working of metals. Hard working and cold working of metals. Here we will see the some videos of hard working and cold working process. this is a